This says how many grams are in 125 point... Oh, no, we already did this one. Sorry. Let's move forward. How many meters... Actually, I want to change this question even. I want to take this one step further. So let's convert kilometers to centimeters, okay? I got you guys a better conversion chart. I did post that on Classroom, but I've got it printed for you here today. And I want to explain what this chart looks like and how we use it. So on the front side is the metric system prefixes, just labeled as U for any unit. Oh, sorry. Just labeled with a U for any unit. And then on the back side, I went ahead and broke it down into the individual units for length and mass and volume and time. But what you need to understand is that these prefixes apply the same way for every type of unit, right? Do you see how every single chart is the same? It just has a different final unit, seconds or grams or whatever. So this is the unit that I think you should start to feel more comfortable with, is using this one, because this is the one that I will give you like on tests and quizzes. You will be able to use this side of it. You will not be able to use this side of it. So this is just to get you familiar and help you kind of figure out what the conversions are and how they work. But in all reality, they apply the same way. Okay, and so that's why I put here 1 kilo unit is equal to 1,000 units. That means 1 kilogram is equal to 1,000 grams, right? It applies the same way. So this is the side I would start to get comfortable with, because this is what you're going to be able to use on tests. The back is just for you to kind of get your bearings on the metric system a little bit. Okay, does that part make sense? Okay, so let's go ahead and look at now our conversion from kilometers to centimeters. What I want to know is there a way that I can go directly, can I do a conversion in one step directly from kilometers to centimeters? I can't, because nowhere on my chart does it tell me 1 kilo is equal to this many centis, right? What does it tell me? It tells me that a kilometer is equal to 1,000 meters, and it tells me 100 centimeters are in 1 meter. So the map that we have to walk through, or the path we have to go, is kilometers to meters to centimeters. Does that kind of make sense? If we're on both sides of this base unit, we have to stop at the base unit in the middle. Okay? So we would go from kilo to meter, then we'd go meter to centimeter. Does that make sense? If we don't have an exact conversion, we're going to have to make a stop in the middle. So let's go ahead and start with our T-chart here. How do we always start our T-chart? With what? With what we know. So we go 0.044 kilometers. And we said our path is going to be from kilometers to meters. So that means kilometers needs to go where on my chart next? Top or bottom? If I want to get rid of kilometers and go to meters, it needs to go on the bottom. Okay, and then I draw another section of my chart. Now I need to get rid of meters and go to centimeters. So how can I do that in my chart? Where does meters need to go? On the bottom. Okay, so let's review here kind of our path. We always cancel fractions or reduce fractions diagonally. So we always reduce them diagonally. We want to make sure one's in the numerator, one's in the denominator. And the units I'm going to look at here, I want to say, oh yeah, we did cancel kilometers. We did cancel meters. We're left in centimeters. Is that what our question asked us for? Yeah, right? Remember, we changed it. We're not asking for meters anymore. We're asking for centimeters. So the unit we're trying to go to should always be in this top right section of our chart. Now we can go in and put in the numbers, okay? So between kilometers and meters, which is the larger unit? Which one gets the 1? Yeah, kilometers. Look on your chart, right? Which one gets the 1 with kilo? 1 kilometer is equal to how many regular units? 1,000. Okay. If you need to be looking at the length side, you can. But remember, we want to get comfortable practicing with this side of our chart. Okay. There's 1,000 meters in a kilometer. And now I'm going to start looking at the next section of my chart. Which one gets the 1 in this section? Meters. Good. And how many centimeters are in a meter? 100. Okay. Anyone have questions about how we found those numbers or where we got those from on our chart? Okay. So now our rule for doing the math is to do what? Multiply across the whole top, divide by the whole bottom. So I'm going to take 0.044 times 1,000 times 100, and I'm going to get 4,400. And what's my unit on the end? Centimeters. Good. Does that meet our expectation? Did we expect a number greater than our starting number? Yeah. We take a big unit and we want to find out how many little tiny units are in there. We should end up with a number that's much, much larger. Okay. How do we feel about the 2-step ones? Do we feel good about that? Whenever we have to cross over the base units part of our chart, then you've got to make sure you stop at that unit in the middle. Right? We're always going to make our chart say 1 equals something else. Okay. All right, let's go ahead and try our next one. What's capital M stand for? Is it milli? Mega. So, I want to go megagrams to grams. Can I go directly there? I think I can, right? Because on my chart it tells me that 1 mega is equal to how many of a regular unit? Right, 1,000,000, okay? So I think I can go directly there. I'll start with what I know, 4.6 megagrams. I want to get rid of megagrams, so it goes on the bottom, and I want to go to grams. If you look at your chart, which one of those gets the 1? Mega gets the 1, and then this is, oops, my zeros are ugly. Okay, so now I've canceled megagrams. I'm left with grams. Can I stop my chart right there? Yeah, all I have to do is do the math, right? I just need to multiply. So I take 4.6 times 1,000,000, gives me 4.6 million grams. Okay. Now, what questions do we have about those ones? Okay. I want to throw one extra problem in here. So just do this one in a blank space on your note sheet. Okay, I want to try this. Convert 32 centimeters to micrometers. Centimeters to micrometers. Okay, this is micro. It's that little U with the tail on the front. Convert 32 centimeters to micrometers. So here's what I want you to kind of see on your chart. They're both smaller than meters, aren't they? But is there ever a direct relationship between those two units in your chart? No, we don't have any spot on our chart that says 1 centa is equal to 10,000 micro, right? It doesn't ever tell us that. So then the path we have to take is we'll go to the base unit and then come back. Because we know what each of those prefixes are in relation to a regular unit, and then we can work backwards to that. Does that kind of make sense? If you don't have a direct relationship, you can always go to the middle and then come back. Okay, so here's what our chart might look like. We would say 32 centimeters. Get rid of centimeters and go to meters. Then get rid of meters and go to micrometers. Okay, we have to go to the middle there because we don't know the direct relationship between centi and micro. Right? You could do the math and figure it out, but for me, it's just easier to take that extra step in the chart and let that math work itself out in one step. Okay? So here my units have canceled, centimeters and meters. That's what I want. Now I can put my numbers in. Which one of these in this section of my chart is going to get the 1? Meters. And so how many centimeters are in a meter? 100. Okay, and then this section of my chart, which one's going to get the 1? Meters. And how many micro are in a meter? Right, I think we had 6 zeros there. 1,000,000. So now I want you to see, do you see how here the pattern is not that the 1 is always on the top or 1 is always on the bottom. We have to pay attention to the bigger unit gets the 1. It's not like it's always going to be on the top or always going to be on the bottom. And it's not even going to be consistent within a single problem. So now I do the math. I multiply across the whole top, divide by the whole bottom. So 32 times 1,000,000. I hit enter. Then I'll divide by 100. And I get 320,000. What would my units be on the end of that number? Micrometers. Very good. Okay. So let's see, does that answer seem reasonable to you? Does it make sense that we have a big number here? Micro is a smaller unit than centi. So there should be a lot of those little tiny micrometers in those centimeters. Okay. How many seconds are in a leap year? So let's answer a couple questions here before we start. Are we going to be expecting big number or small number? Big number, right? A lot of seconds in a year. But what do we know? They didn't even give us a number here to start with. But what do we know? Okay, a leap year happens every 4 years, but what do we know specifically about what happens in a leap year?
There's an extra day.
There's an extra day. So how many days are in a normal year?
365.
365, which means a leap year must be 366 days. That's going to be what we start with. Right? Okay, so let's think about our path here. We're going to need to go days to what? If we want to get our way to seconds, what can we go from? Do we need to go days to months?
Hours.
No, we need to go days to hours, then to minutes, and then to seconds. Good. So that's going to kind of be our path. If you're not sure about conversions, I think it's going to be helpful for you to kind of walk out that path before you get into your T-chart so you can kind of see where you're going to be going here. But if you feel comfortable, you don't have to. We're going to get rid of days and go to hours. Get rid of hours and go to minutes. Get rid of minutes and go to seconds. Okay, do we see how we went diagonal with all of those? Right, what I want to go to is going on the top. What I need to get rid of goes diagonal on the bottom. So now I can put in my numbers. Okay, which one gets the 1 here, hours or days?
Days.
Days, and how many hours are in one day? 24. Okay, so days is gone. If I stopped my math right now, I would be in hours. Right, if I did the math right now, I would be in hours. That's not what I want. Now I'm going to come here and say, is there 1 minute in 60 hours or is there 1 hour in 60 minutes? 1 hour and 60 minutes. So now hours has canceled. If I stopped now, what unit would I be in? I would be in minutes. Now I'm going to come back and say 1 minute is equal to 60 seconds. And minutes has canceled. So now my answer will be in seconds, which is what I was wanting. Okay. Okay, be really careful with this because I'll see some people say 1 hour is 60 seconds. Right? That's not really true. So you got to make sure you get through all of that conversion right there. Okay, let's go ahead and do the math. We multiply across the whole top, divide by the whole bottom, which in this case, do we need to divide by the bottom? No, because the whole bottom is just 1. So I get a big, big, big number. 3162240 31,622,400 seconds. Okay. This one, is this a U.S. conversion or is this a metric conversion? The top one here.
US.
It's a U.S. conversion because both are in U.S. units. The bottom one, is it U.S. or metric? Metric. Okay, so I want you to try each of these on your own. Oh, sorry. I want you to try each of these on your own, and I'll start working them out here in just the next minute or two. This first one I was able to do in one step because I knew exactly how many feet were in 1 mile. So I could do that just in one step. We should have been expecting a really small number here, right? If we know that there's 5,000 feet in a mile, I know that this is only a small fraction of that number. Okay, that's only a fraction of a mile. So I ended up with 0.0652 miles. Okay, where you rounded that was really not that important. But were we somewhere in the ballpark there? Okay, and then on the second one, I had to stop at seconds in the middle, right? I went from milliseconds to seconds. And then I went from seconds to kiloseconds. And we should have been expecting a really tiny number here, right? Because millisecond is a really small unit. And kiloseconds is 1,000 seconds. So I ended up with a number that looked like this. Some of you might have seen a number 2.3 e to the negative 4 in your calculator. That means 2.3 times 10 to the negative 4th. That's the same number as that. Did anybody have that in their calculator? Okay. We'll work with scientific notation in a little bit, but this is what I should have ended up with here. We're going to look now at U.S. and metric system conversions, right? We are the ones that need to know how to do this because if we take our measurements in inches or in pounds, we have to know how to get them to the metric system now. Okay, so this chart, I think I gave this to you in your slides. Is that right?
Yeah.
Okay, if you notice, I tried to give the bigger unit always the 1. So it's not like the metric unit always gets the 1 or the U.S. unit always gets the 1. The larger unit, I gave the 1. Okay? These two measurements both measure what? Length, mass, volume, time. What do those all measure? Length. What about these ones? Mass, good. And then what about this last one down here? What does it measure? Volume. Okay. I spelled length wrong, like really wrong. Sorry. Usually a pretty good speller, but I guess not today. Okay. If I were you, I would maybe start to memorize. I would pick one of the length conversions to memorize, whether it's inches to centimeters or meters to feet. Pick one of those to get really familiar with. And the same thing here, pick one of the mass to get really familiar with. You don't need to memorize both of them because if I know how many inches and centimeters, how they relate, then I can always convert from feet to inches to centimeters back to something else. You know what I'm saying? I can always work my way to get to that inches to centimeters conversion. Okay? All right, let's go ahead and try one here. How many grams are in 4.3 pounds? How many grams are in 4.3 pounds? So what conversion do we have that allows us to go from grams to pounds? Do we have one that goes directly from grams to pounds? What do we have?
Ounces to grams.
We have grams to ounces, or we have pounds to kilograms. Either one of those would work fine, right? I'm probably going to go pounds to kilograms, then to grams, right? That would be my choice for the path we go. But you could also go pounds to ounces to grams, and you get the same thing. Okay, so it doesn't matter which path you choose to get from start to finish. Okay, but I'm going to go ahead and go 4.3 pounds. All right, so if I want to go pounds, I said I was going to go pounds to kilograms. So pounds to kilograms, and then I'm going to go kilograms to grams. And let's go ahead and put my numbers in then. Between kilograms and pounds, which one gets the 1?
Pounds.
Look on your chart. Kilogram gets the 1, and how many pounds are in 1 kilogram? 2.2. Okay, so now pounds is done. If I stopped right there, I would be in kilograms. Now between kilograms and grams, which one gets the 1? Kilograms. Right, now this is a metric conversion, so I go back and look at my chart and say there's 1,000 grams in a kilogram. So my kilograms have canceled, pounds has canceled. I'm left in grams. So I'm going to take 4.3 times 1,000 divided by 2.2, and I get 1,954.5 grams. If I were to do the other conversion, okay, if I were to go 4.3 pounds to ounces, then ounces to grams, right? We said that's the other path we could have taken. Pounds to ounces is 1 pound is 16 ounces, and then 1 ounce is 28 grams. So if I take 4.3 times 16 times 28, I get 1,926.4 grams. That's pretty darn close to what we got using that method, right? So you can do them either way, right? You can choose whatever path you prefer. You're going to get the same answer, okay? All right, let's look at the second one now. Inches to meters. Inches to meters. What is a possible path we could take to go from inches to meters? Good. Inches to centimeters, then centimeters to meters. That's one possible path. What's the other one that we could take?
Inches to feet.
We could go inches to feet and then feet to meters. Either one works fine. Okay, because I've got both conversions on my chart. I know how many inches and centimeters relate, and I know how feet and meters relate. So you just pick the one that works best for you. Okay, I like to go inches to centimeters. So I'm going to go 4.32 inches. And I'm going to choose to go this route, inches to centimeters to meters. You can do it the other way and see if we get the same answer. Okay, I'm going to get rid of inches and go to centimeters. I'm going to get rid of centimeters and go to meters. Now let's go ahead and plug in my numbers here. Between inches and centimeters, which one gets the 1? Inches. And I know there is 2.54 centimeters in an inch. That comes right off that US to metric chart that I gave you. Okay, so now inches is done. If I stopped now, what would my unit be in? Centimeters, which is not what I want. Now I need to get rid of centimeters and go to meters. So where does the 1 go here? Meters, and then centi gets 100. So I'm going to take 4.32 times 2.54 divided by 100. I want to make sure I hit enter after I do my numerator. Multiply across the whole top, I hit enter, and then I divide by the whole bottom. So I get 0.1097 meters. Does that answer seem reasonable? Did we expect it to be a small number? Very good. Okay. Why don't you try that last one on your own? Try the last one here on your own. Centimeters to feet. Centimeters to feet. So 2 paths you could take. You could go centimeters to inches to feet, or you could go centimeters to meters to feet. You can pick which one you think works best.